Hello everyone. So today we will going to study or we will going to see some previous year questions which have been there in the JEE examinations in the previous years. So hope you are very well. So let's start the NCERT chapter 2 Electrochemistry JEE PYQs part 1. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. So let's begin with our first question. And this is a JEE PYQ which covers the NCERT section 2.4.2 in the chapter Electrochemistry. So the question says that plotting 1 by lambda m against C lambda m for aqueous solutions of a monobasic weak acid HX resulted in a straight line with y-axis intercept of P and slope of S. So here in this statement, the question is describing a graph where it is saying that we are plotting the graph 1 by lambda m against C lambda m. So this is the variables y to x, 1 by lambda m against C lambda m for the aqueous solution of monobasic weak acid. Now we are considering here the solution of monobasic weak acid. Let's say it is HX, right? Resulted in a straight line, and the plot or the graph which you are plotting for 1 by lambda m to C by lambda m for a weak acid HX, the graph is a straight line with y-axis intercept of P, and straight line is the graph is a straight line which is having an intercept of P on the y-axis and slope of S, and slope is S. Okay, so the graph is a straight line and the intercept of the graph at the y-axis is P and the slope of the graph is S. The ratio P by S, that means intercept to the slope, is, so you have to determine the ratio P by S here, that means intercept on the y-axis to the slope of the graph. This ratio you have to determine, and we have there is the mentioned some quantities already here, like lambda m, which we are using in the question, is molar conductivity. Lambda m naught is limiting molar conductivity. C is molar concentration. C is representing molar concentration, and Ka represents dissociation constant of HX. Ka is not taken and lambda m naught is also not taken in the question, right? So you can use it as a hint to solve the question, that we are going to use lambda naught m and Ka in the solution of this question. That's why it is given in our question, right? So this question has been into the 2023 advanced examination. The options related to this questions given are Ka lambda naught m, Ka lambda naught m by 2, twice of Ka lambda naught m, or 1 upon Ka lambda naught m. So these are the 4 options you have. So you have everything given regarding the graph, and between which quantities the graph has been drawn, this is also given. The representation of intercept and slope is also given. You have to find the intercept to the slope ratio, right? Okay, so you have some time, just go through it, try to try to solve it, okay, try to conclude it. and then we will see its correct answer. Okay, so now let's see the correct answer. So for this given question, the correct answer given is option A, that is Ka times lambda m naught. Now let's see how this is the correct answer. That means how the ratio of P by S, or the intercept by the slope, is equals to Ka times lambda naught m. Degree of dissociation, that is alpha, for a given aqueous solution is given by lambda m upon lambda m naught. Okay, so the fraction of the molar conductivity divided by the limiting molar conductivity. So the alpha, so degree of dissociation is represented by alpha, and alpha is given by the fraction of molar conductivity to the limiting molar conductivity. Let's suppose this is our first equation, and also this is the formula or the equation given in our NCERT textbook and marked as the equation 2.26. Now dissociation constant, which is Ka, for a given aqueous solution for the weak acid. So Ka is given as C alpha square upon 1 minus alpha. Okay, so we describe the dissociation constant in terms of the degree of dissociation, and the concentration is C times alpha square. That means C times the square of the degree of dissociation divided by 1 minus degree of dissociation. Now let's say this is the second equation, and this is the equation in the NCERT textbook marked as 2.27. Now we just have to put the value of alpha from the first to the equation second. Okay, so we put the value of alpha, that is this value, in the equation second. So what we will get, therefore Ka equals to C times, so wherever alpha it is, you just have to write the lambda m by lambda m naught at the place of alpha. So C times lambda m by lambda m naught whole square divided by 1 minus lambda m by lambda m naught. Okay, this was this will be the equation become when you put the value of alpha and as per given in the first equation in the second equation. Okay, solution to be continued. So let's see. So now we just simplify it more. So we have C alpha square upon 1 minus alpha. Alpha we have put as lambda m by lambda m naught. Now we simplify it. So the equation will become C lambda m whole square divided by lambda m naught multiplied by lambda m naught minus lambda m. Now how we conclude at this? So we have taken that Ka equals to C lambda m by lambda m naught square, right? C alpha square upon 1 minus alpha, that means 1 minus lambda m by lambda m naught. This was the equation. Now when you simplify it, you take the C lambda m square in the numerator, and this lambda m naught square will go in the denominator in the multiplication. So here we will go with lambda m naught whole square, and this 1 minus lambda m by lambda m naught we take the LCM. So lambda m naught will be there also. So lambda m naught minus lambda m by lambda m naught. This will become this. Okay. So 1 minus lambda m by lambda m naught. When you take the LCM at both the sides, then this will become lambda m naught minus lambda m upon lambda m naught, right? Now, if you can see that this lambda m naught square is in multiplication with this bracket, that means lambda m naught here and here, one can cancel out, right? So you just cancel out the one, and the remaining term is C lambda m square divided by 1 lambda naught m multiply by lambda m naught minus lambda m, right? Simple. So we just simplify this equation to this. Then we just multiply it, cross multiplication to get the value or to get an equation, right? Why we are want to getting an equation? Because as it is already given in the question that the graph between the 1 by lambda m and C lambda m is a straight line, right? That means we want to conclude a straight line equation from this experiments or this results, right? So we try to make it an equation by cross multiplication. So we multiply this whole term in the denominator to the Ka will be equals to C lambda m square. So Ka times lambda m naught whole square. So lambda m naught, when you multiply it inside the bracket, it will become Ka lambda m naught whole square minus Ka lambda m naught lambda m equals to C lambda m square, right? We simply in the denominator first of all multiplied the lambda m naught in the brackets, and then we multiply the denominator with the Ka by cross multiplication, and we get this equation. Now we try to more simplify it. So what we will do, we take one of the lambda from here at the right hand side to the left hand side equation and divide it. Okay, so here the lambda m is in multiplication. When it go at the left hand side, it will go in the denominator to the overall equation, right? So it will become Ka lambda m naught square upon lambda m minus Ka lambda m naught lambda m upon lambda m. Now one lambda m is already present in the numerator, so they will cancel out. When you divide this term with lambda m, there is already one lambda m present, so it will cancel out with the denominator lambda m which you have taken from this. So the rest of the equation will be Ka lambda m naught whole square upon lambda m minus Ka lambda m naught equals to C lambda m. This will be the equation, right? Now we will try to more simplify it. We will simplify it until we will get an equation of a straight line, as it is given that the graph is a straight line, and we then compare it with the straight line, and the variables we will we want to get in the main equation is 1 by lambda m and C lambda m, because these are the variables between which we are drawing the graphs. We are considering our graph, right? So until when we obtain these two as our variables, as our x variable and y variable in a straight line equation, until then we will try to simplify it more. So when you simplify it more, it will become Ka lambda m naught square upon lambda m. This minus Ka lambda naught m, you will take it the right hand side, it become positive. So C lambda m plus Ka lambda m naught. Now we have to take 1 by lambda m and C lambda m. Okay, you have to take 1 by lambda m as y and C lambda m as x. In the equation, y equals to mx plus c, which is an equation of straight line. Y represents the y-axis variable, x represents the x variable, m is representing the slope, and c is representing the intercept. Here c is p and m is s, as per the given question. So at the left hand side we should have y. That means we should have 1 by lambda m. So if you only take 1 by lambda m from this Ka lambda m naught square by lambda m, 1 by lambda m you take, rest of the things will go at the right hand side. So this Ka times lambda m naught whole square in the numerator will go in the denominator at the right hand side, and the equation will become 1 by lambda m equals to C lambda m upon Ka lambda m naught square. You will divide this Ka lambda naught m square by both the terms, right? So you divide it with the first term, and then you divide it with the second term. So in the second term, if you observe, Ka lambda m naught is already present, and when you put in the denominator to it Ka lambda m naught square, 1K and 1K will cancel out, and 1 lambda naught m and 1 lambda naught will also cancel out. The remaining thing is 1 by lambda naught m, right? So this is the remaining equation. Let's say this is equation third, because we have already taken the two equation as first and second. So this is equation third, let's say. Now what you do the comparison between the equation third and the straight line equation, which is given by y equals to mx plus c. You can say it C prime, because C we are using as molar concentration is in this question. So C prime. Now when you compare these two equations, you will get slope, that is m, which is 1 by Ka lambda m naught square. So basically 1 by lambda m equals to some amount m multiplied by the C lambda m, because we have to take the x variable as C lambda m and y variable as 1 by lambda m, right? So 1 by lambda m is y variable. Now slope multiplied by C lambda m. So accepting the C lambda m, whatever is present in this equation here, that is considered as slope. So the slope will be 1 upon Ka lambda m naught square, which is S as per the given question, right? Mx plus C prime. Okay, so whatever here will be the intercept. So intercept is given by C prime equals to 1 upon lambda naught m, which is equals to P, which is represented as P in this equation. Now what you have to find out in the question, the ratio of P by S, that is the ratio of intercept to the slope. So P by S will be 1 by lambda naught m upon 1 upon Ka lambda m naught square. So this will go here and this will go here in the numerator, right? So when you write it as Ka lambda m naught whole square upon lambda m naught, 1 lambda m naught will cancel out with another lambda m naught present in the numerator, and the remaining thing is Ka times lambda m naught, right? So this will be the ratio, and this will be going to our correct answer. Okay, now let's move on to our next question. Okay, so this question says that, okay, this question is a JEE PYQ question, and this covers the NCERT section 2.4.1 in the electrochemistry chapter. The question says that molar conductivity, which is represented by lambda m, of aqueous solution of sodium stearate, which behaves as a strong electrolyte, is recorded at varying concentrations of sodium stearate. But we are saying that at the various concentrations of sodium stearate, that means at various values of concentration, that is C, for the sodium stearate, we have observed the values of molar conductivity. Which one of the following plots provides the correct representation of micelle formation in the solution? So you have to tell that, as you can see that we have given some options. So as per the given options, which plot is providing the correct representation of micelle formation in the solution? Now critical micelle concentration, which is CMC, is marked with an arrow in the figures in the option. CMC, critical micelle concentration, is a concentration at which the micelles start to form. Okay, so you have to choose the correct plot as per the given question. So this question has been in 2019 advanced examination, and the options are the A figure, where there is a graph between the lambda m and the under root c, and the graph is you can say two lines intersecting with each other, or you can say two half lines intersecting with each other. Okay, and there is a graph B, whereas there is a graph between the molar conductivity and the under root c under concentration, and there is a graph where this line is coming like that, straight line, and then it is a slightly going backward with respect to the under root c value, right? And the arrow is here representing the CMC. Similarly, the option C, in which the graph is present between the molar conductivity and the under root concentration, and this graph is kind of inverse of the graph A, right? This is like this, and the CMC, that is the critical mycelic concentration, is pointed at this observed point. Okay. Similarly, in the graph D, the graph between the molar conductivity and the under root concentration, and the graph is this shown by this lines, two lines joining at this point, which is represented as CMC point. Okay, so you have to select the correct graph. Okay, so you have some time, go through this and try to conclude at the correct option, and then we will see what will be the answer. Okay, let's see. So for this given question, the correct answer is option B graph. That is this one, where the two lines are joining together, and this joining point is depicted as CMC. So this graph, where this point or joining point is CMC of lambda m on the under root c, has a small negative slope. Okay, so if you can see, this has a small negative slope, because if you remember, this is the x and y representing axis, and if this is the straight line going for a graph, then the slope of this will be positive. But if the line goes like that, okay, in the decreasing way, then its slope will be negative. Okay, so as both the lines are going like that, so there will be a little negative slope for this graph. Now this above particular concentration, sodium stearate forms aggregates which are known as micelles. Above a particular concentration, that means at a particular concentration, if you go more than that particular concentration, the sodium stearate starts to form aggregates which are known as micelles. The concentration, that particular concentration, is called as CMC, critical mycelic concentration. Since the number of ions decreases, and hence the molar conductivity will also decreases, because they starts to aggregate, right? So that's why the number of ion decrease, and the molar conductivity will also decrease after this CMC. Okay, that's why we have this decreasing graph. Hence the option B is the correct answer. So this graph is correctly showing the critical mycelic concentration, which is marked as per this given arrow. Okay, so B option is the correct answer. Okay, let's move on to the next question. Okay, now this is a JEE PYQ, and this is covering the NCERT section 2.5 in our chapter Electrochemistry. So the question says that electrolysis of the dilute aqueous sodium chloride solution was carried out by passing the 10 milliampere current. Okay, so what we are saying that there is a dilute aqueous sodium chloride solution and we have to do the electrolysis of that. So we are doing the electrolysis of this NaCl solution by passing the 10 milliampere current through it. Now the time required to liberate 0.01 mole of H2 gas at the cathode is now. So here we are talking about the electrolysis of electrolytic solution of sodium chloride, where we are passing the 10 milliampere current and we are saying that the time which we require, you have to tell the time which we are requiring to liberate this much amount, only this much amount of H2 gas in this electrolysis process at the cathode electrode. Okay, so we have also given the 1 Faraday value. You can take it as 96500 coulomb per mole. Okay, so the given 4 options are, so you have to tell the time. So time, as you can see that options units are seconds, right? That's why you have to calculate the time here. So sometimes what student will do that they just read the question once and they start to solve. They even don't know what to find, right? But try to remember or try to concentrate that what is the question asking first of all, that which you are solving, because sometimes you just relate the question with some concept which you have studied recently or in the back time, but so that's why you start to relate the question with that particular concept and you start just solving. Meanwhile the question asks something else, so try to focus on the understanding of the question and then start solving the question after seeing that what question is asking. So the options given are 9.65 times 10 to the power 4 seconds, 19.3 times 10 to the power 4 seconds, 28.95 times 10 to the power 4 seconds, or 38.6 times 10 to the power 4 seconds. So you have given some time, go through it, try to solve it, and then we will of course see that what is the correct answer. Okay, let's see. So for this given question, the correct answer is option B, that is 19.3 times 10 to the power 4 seconds. So this much time you have to need to deposit the 0.01 mole of the hydrogen gas at cathode. Let's see how. So 0.01 mole of H2 is equals to 0.02 gram equivalent. If you talk about the mass, if you are talking about 1 mole of H2, that means you are having 2 gram of H2, right? Because H2 means 1 gram plus 1 gram, right? Similarly, if you are talking about 0.01 mole of H2, so if you are talking about 1 mole, that means 2 gram of H2. If you are talking about 0.01 mole, that means we are talking about 2 times 0.01 mole. 0.01 gram, that means 0.02 gram equivalent, right? We just apply the unity method, and therefore the coulombs that will be required for this gram equivalent of liberation of hydrogen will be the weight multiplied by the Faradays. Okay, so Q equals to NF. So the N is 0.02 multiplied by the Faraday. Faraday is 96500, that you have to take as given in the question. When you multiply these, it will become equals to 1930 C. C is for coulomb, which is a unit of charge. Now you also know that Q equals to IT, right? That means the current multiplied by the time. For what amount of time the current is passing so that the charge will flow, right? So Q equals to IT. Now as you know that we have after knowing that how much amount or the weight of the hydrogen we needed to liberate, we just describe or we just determine the charge, okay, that we will going to use while applying the electricity, while applying the current. So we know the Q, we know the I already given 10 milliampere current, right? We have to tell the T, we have to tell the time. So you just simply put the values in this equation. So Q equals to IT and Q is 1930 coulomb. So T will be Q divided by I. So 1930 divided by the I, the current, which is 10 milliampere. You just have to convert it into the amperes. So milliampere to the ampere, what you have to do, you just have to multiply it by 10 to the power minus 3, or you can say you just have to divide the ampere by 1000. So 10 multiplied by 10 milliampere means 10 multiplied by 10 to the power minus 3. This will be the time. So when you solve this, the time finally comes out as 19.3 multiplied by 10 to the power 4. Because if you can see that 10 to the power plus 1 and 10 to the power minus 3 will become 10 to the power minus 2 here, plus minus minus, 3 minus 1 will be 2. So minus 2 when you go in the numerator, it will become 10 to the power plus 2, right? And if you put the decimal here in the answer, if you are putting the decimal here, that means you have to add the 10 to the power 2 more, right? That will become 10 to the power 4, because if you solve this, it will become 1930 00, right? 193000. So already 10 to the power 2 is here for 2 zeros, and if you are putting the decimal here, that means you have to put the 10 to the power 2 more. So that's why the answer is 19.3 times 10 to the power 4. Okay, so the correct answer is option B. Okay, now moving on to our next question. Now this is again a JEE PYQ question, and this is covering our NCERT section 2.1 in the electrochemistry chapter. The question is that in the electrolytic cell, flow of electrons is from. So as per the given options, you have to choose the one which is describing the correct flow of electrons in the electrolytic cell. The four options are cathode to the anode in the solution, cathode to anode through the external supply, cathode to anode through internal supply, or anode to the cathode through the internal supply. Okay, so try to solve it and try to come at the conclusion, and then we will see that what is the correct answer. Okay, let's see. Okay, now for this question, the correct answer is option C, that is cathode to the anode through the internal supply. So in the electrolytic cell, electrolysis is the process occurs which is at the cost of electricity. Okay, electrolysis process occur at the cost of electricity. That means when you pass the electricity, then the electrolysis process occurs. So at cathode, this reaction takes place, which is Mn positive. That is at the M element which is present at the cathode, the N positive is the charge, and when it gains the same number of electrons, it will become a neutral M. This is the reaction of the reduction going on the cathode electrode. Similarly, this is the electron gain in the solution, right? This is an electron gain because we are adding the electrons to the ion. So electron gain in the solution. And similarly at anode, the X having the N negative charge, that means extra charge, will release the extra negative charge and become a neutral X, right? So this is the oxidation process happening at the anode, and this is electron supplied to the anode. This is the process of electron suppletion to the anode. Therefore, the electron is moving from cathode to anode via internal circuit. That's why we are saying that the electron is moving from the cathode to the anode, because from the cathode electron gain in the solution is happening, and at the anode the electron is supplied to the anode, right? So cathode to the anode, the electron is moving via internal circuit. Okay, via internal circuit. So the correct answer is option C. Okay, let's move on to our next question. This is a JEE PYQ question, and this is covering the NCERT section 2.5. The question says that Faraday's laws of electrolysis are related to the. So the law given by the Faraday for the electrolysis are related to which concept? As per the given options, you have to select the one, the correct one, right? So the four options given are atomic number of the cation, atomic number of the anion, equivalent weight of the electrolyte, or speed of the cation. So you got some time, go through it, and then we will see that what is the correct answer. Okay, let's see. So for this given question, the correct answer is option C, which is equivalent weight of electrolyte. So the Faraday's laws of electrolysis is related to the equivalent weight of electrolytes. Okay, as the number of Faradays passed is equal to the number of gram equivalent of the electrolyte discharge. So the Faraday law says that the number of Faraday, or the number of charge of the Faraday which is passed through a solution, is equal to the number of gram equivalent of electrolytes which is discharged. Okay, so because the amount of the electrolytes which is discharged will be needed the same, so the solution will be needed the same amount of charge, right? The same amount of charge that is discharged, the solution will need the same amount of charge as per the Faraday. That's why the number of Faradays that is passed is equal to the number of gram equivalent of electrolytes which are discharged. Okay, that's why we are saying. So basically the Faraday law of electrolysis is related to the equivalent weight of the electrolyte. We will consider the gram equivalent or equivalent weight of our electrolyte. Hence the correct answer is option C. Okay, moving on to our next question. Now this is a JEE PYQ question covering the NCERT subsection 2.4.2. The question says that which out of the following is a correct equation to show the change in the molar conductivity with respect to the concentration for a weak electrolyte if the symbols carry their usual meaning. Now whatever the symbol we are using in the options, they are carrying their usual meanings. That means lambda m is denoting the conductivity or the molar conductivity, lambda naught m is denoting the limiting molar conductivity, C is denoting the concentration, A is denoting the constant, and K is denoting the equivalent constant, right? So you have to tell the correct equation which is present in the option, to show the change in the molar conductivity with respect to the concentration for a weak electrolyte. Okay, so this question has been into the 2024 mains examination. The four options given are lambda m minus lambda m naught minus a under root c equals to 0, lambda m square c minus ka lambda m naught square plus ka lambda m naught equals to 0, lambda m minus lambda m naught plus a under root c equals to 0, or lambda m square c plus ka lambda m naught square minus ka lambda m naught equals to 0. Okay, so try to solve this as per the question given, that you have to choose the equation which is correct to show the change in the molar conductivity with respect to the concentration for a weak electrolyte. Okay, and then we will see that what is the correct answer. Okay, so let's see. So for this given question, the correct answer is option B. This equation is the correct equation, that is lambda m square c minus ka lambda m naught square plus ka lambda m naught equals to 0. So for a weak electrolyte, as in the question we are asking about the weak electrolyte. So for a weak electrolyte, the equation is like HA, reaction is like HA dissociates into H positive plus A negative, where the Ka for this will be alpha square C divided by 1 minus alpha. Alpha is representing the degree of dissociation, and this is the equation mentioned as 2.27 in our NCERT textbook. Now when you solve this, it will be alpha square C equals to Ka minus Ka alpha, right? So it will be Ka minus Ka alpha, and then when you solve it and when you take it as an equation, so let's say alpha square C plus Ka alpha, this one, minus Ka equals to 0. This became equation. Now you have to put the value of alpha into this. Alpha is given by lambda m upon lambda m naught, right? Degree of dissociation is the fraction of the lambda m to the lambda m naught. So we just put the alpha equals to this. So alpha square, that means lambda m upon lambda m naught whole square times C plus Ka times lambda m by lambda m naught minus Ka equals to 0. Now this is the equation. You can say that this is a quadratic equation. Okay. So when you solve it more, it will be lambda m square C plus, you just have to take here the lambda m naught square, right? Here it will come lambda m naught square, and you have to divide it through the whole equation. Okay, so it will become, you just have to take the LCM basically. So it will be lambda m square C plus Ka times lambda m multiply by lambda m naught, because if you multiply here by lambda m naught whole square, one will cancel out and one will remain as it is. Then minus Ka multiply by lambda m naught whole square, because we have taken the LCM, right? Lambda m naught whole square, you have to take it as an LCM and make the denominator common. So the final equation get you will get is this, and this will be the correct answer, which is our option B, right? So this is the correct answer. Okay, so that's all for today's chemistry session. Thank you so much for joining this session. Thank you so much.